At this part, we're gonna model a rounded table with conical feet. So first of all, as you know, I should specify the template family, which is metric furniture. I open it. I'm gonna tell you the basic tasks that you have to do in the process. Firstly, I'm gonna model the feet of the table. Here I sketch a circle by this way, as you can see. And then I associate the radius to a parameter R1, which is 55 millimeters. Then at the top, I sketch another circle, which its radius is 100. I associate R2, then I click on finish. So the cone is prepared. Let me check it in the view. Okay, what is next? Excellent. I sketch a reference plane by this way, as you can see. Then I extend the conical shape to connect it to the reference plane. I measure the distance of height and I associate it to the parameter. I name it h1. I specify it as an instance property. I will talk about it later. Check it out in the 3D view. We got the reference planes at the center of the shape, so we can use them for the alignment to some other geometries. 25 for R1 and 70 for radius 2. Or let me specify 50. Apply and OK. I open 3D view. I save the feet or the model. I save it as leg. Okay, I open another family template file in metric furniture. Very well. And then at this template file, I'm gonna load the feet or the leg. By this way, I load it in the family 7 and then I place it right here. And let me save the template file as table. Well done. And then in create tab, I pick extrusion, circle for the rounded table. Very well. I associate the radius to R or radius. Well done. Finish. Left view. Then for controlling the height, again I sketch another reference plane to align the table to it. When I measure the distance, I'm gonna consider the reference plane at the top of the table. So let me associate the parameter to the dimension. I name it h. Well done, okay. Then I align the table to the reference plane and also locked. By this way, let me specify a value for depth, 7 centimeters. Remove constraint and then I move it again to connect it to the reference plane. We got the same problem with moving the object. Let me make a copy. As I told you before, you can use this join. Just check this join and then you can move the geometry, or you can make a copy. I align the table with the reference plane and the thickness of the table is fixed, 7 centimeters. Here if I modify height, does it change the thickness of the table? 1200, apply. As we talked about it before, I'm not sure if you remember or not, but I want you to give the answer that what should we do here. Actually, we could have use a nested family at this context. Then we could be able to modify the height of the object easily. But as I told you before, I should sketch a reference plane just beneath the table. In order to constrain the thickness of the table, I lock it. I measure the distance between these two reference planes or the thickness of the table, and then I lock it. So this would constrain these. Even you can associate a parameter to the thickness so that you can control the thickness of the table. Check this out, everything is okay. Anyway, but what is the next stage? We need to be able to control the height of the leg or feet. I want you to watch this part carefully, since there are some times that you got on a specific object that you got no associated parameter for controlling the height of the object, like this situation. As you can see, the height of the feet is not equal to h, while h is associated to the height of the table. So how can I control the height of the feet? I open family types. Then I create a new parameter. For instance, I name it h1, which refers to the feet or leg. Okay. Then I define the formula for h1. I subtract 70 millimeters from h. I'm just preparing a parameter for controlling the feet. Let me find the dimension. I associate h1 to h1. Then it will be connected to the table. Well done. So there are some time that we have to create a new parameter, make it prepared, and then associate it. And as you can see, the problem is solved. Let me test the parameters in family types. 90 centimeters for the height. Apply. Okay, well done. It seems that everything is okay. However, the places are not aligned. I select the feet and then I place it right here or at the right position. Right now, how can I associate a parameter for controlling the place of the feet? While you're working with rounded geometries, at first you should sketch some reference planes by this way. You should sketch the reference planes by this manner, like this way. Wait for a second. Check this out. Then I measure the distances, align distances between the reference planes and equalize. Then I associate the parameter. And also to the top part, let me edit the witness lines to measure the distance, equalized. Then I associate the parameter. I select the new parameter. Then I name the parameter as the diameter, since it controls the diameter of the circle. Very well. I open edit types. Let me associate this one. These two sides should be equal to each other. And then in family types, I want to define a formula. I multiple r into 2 for calculating the value of diameter. Let's check it out. The reference planes are connected to the circle. So from now on, we got no problem or challenges in the alignment. However, I can measure the distances between the reference plane and then make them equalized. And this is optional. We can ignore it, but I do it. Check this out. I mean, the previous equalizations were obligatory, but this is optional. But right now, if I equalize these dimensions, then I can align the feet with these reference plane. By this way, I place it at the cross sections. At such a condition, you should have imported your nested family, since we are not able to align the families which are not a nested family. Then I make some copies. Then I align the copied ones. By doing this manner, the positions of the feet are always fixed, even if I modify the radius. However, I could have associated a parameter instead of equalizing them. I mean, I could have measured the distance at first by this way, and then horizontally I measure the distance. Then I select these two dimensions to associate them to a new parameter. I named it d2, and then I can define a formula for it. For instance, d2 is equal to r, or radius, divided into, for instance, 3. I click on apply. Let me check. It is at a suitable position. For multiple in 2. Better now. Or 2.5. Let's check out the new position of the feet. Well done. So if we agree, let's test these. I want to open the family types and then check the parameters if there is any problems. 1200 for radius. Well done, they are well adjusted. 1500. Very well. 800. Then we're gonna go through voids, which got a simple process. In create tab, I pick sweep tool. I've been always using solid tools and then void it, since by this way I got much more control on the sketch. At first I specify the edges as the path, finish, and then edit profile. And I will talk about some points about nested families related to this here. And viewer, you can use it if you don't want to specify a value for the distance. It provides you a temporary view that is not maintained in the project browser. And as you know, it is useful when editing or sketching your profiles. I sketch the void. Well done, finish. Then I close the viewer. And as you did see, you can see the measurements and the dimensions in the viewer. Then I specify void, and then I click on cut. Well done, let's check it out. The sketched part around the table is cut, as you can see, or voided. Let's test the parameters. First of all, radius, I define 12 hundredths, apply, and then for the height, 6 hundredths, apply. Very well. Okay,